Okay, let's give you guys some practice. So here's the here's your function f of x equals this thing here. So this is your function here. Okay, so this corresponds to this here. Now we if you so this is your arc here from 1 to 2. If you rotate this arc 360 along the x-axis, you would get this. Work out the surface area of this. Okay, so here's a form. So here's a formula for the surface area. So when you look at this, this is your arc length. Okay, so once you've got your arc length, then rotate it 360. So 2 pi r it. So this is your 2 pi r. This is your circumference. Well, looking at this, you should work out the derivative and then square it and then add 1 and then square root it. The thing is, in the past, when we come to do this bit in the past, we would write it in the form of something squared, so that we can use this square root to kill off this thing. That's an old method, but in this one here, you've got root x lingering around, so you've got root x here. So when it comes to this bit here, leave it in the form of something root x, so these two will cancel each other out. You will see what I mean when you get to this stage. But in the past, when we get to this stage, we would write it in the form of something squared, and then later on square root this. These two will kill off each other. But in this case, you've got this thing lingering around, this square root here. Use this square root to later on cancel out with the square. You see what I mean when you get there. Okay, so press pause and have a go. Okay, so looking at this, we need to find the first derivative. So this is our function at the moment. So rewrite our function as this. Hang on. Rewrite. So this is our function here at the moment. We differentiate it. It will give you this, and then square it. It will give you this, and then add 1 to it. So that will then give you this. Okay. So in the past, when we get to this stage, we would try to rewrite in the form of something squared. But when it comes to the surface area, leave it as it is. So put this whole thing here into here. Okay. So that will then take you to so if you put this, hang on, if you put this into this, it will give you this. Okay. So this is your f of x here. F of x is this. This is our function. Don't forget. And then we're evaluating it from 1 to 2, and then merge these two together. So that will give you 4 pi. 4 pi. And then when you get to this bit here, you can rewrite the 1 as x over x. Whenever you have x over x, just bear in mind that it breaks down when x is 0. Okay, so you are allowed to do this, but every time you have something over x, then just bear in mind that the whole thing breaks down when x equals 0. Luckily, we're not integrating it from 0 to something. Okay. Well, anyway, rewrite this as this, and then blah blah blah. This is a constant. Remember, we are integrating with respect to x. So this here contains x. This here contains x. This 4 pi here doesn't contain x. Take it out here. Okay. And then this will cancel out with this. So that will then take you to here, and then integrate it. So integrate it, and then you will get to this stage, and it's just a matter of tidying it up. So that will then give you this, and notice that here you can factorize this out. So you've got 2 bracket 3 root 3 minus 2 root 2. You can see that the 2 is in common here. So take the 2 out. So this then becomes an 8. Okay, and then take the third out. Take the third out as well. So it becomes this. It's not important, but it's just neater. Okay.